Hello everyone, this is Ms. Williams, and this is the third video in this unit. Today we're going to do two different topics. We're going to graph radical functions, and we are going to find the inverse of functions. So those are your two I can statements, if you want to put those at the top of the page. And we'll get started. So if you remember back, we did parent functions when we did quadratics. Alright, so let's start with, what does the parent function of y equals the square root of x look like? Well, there's several ways you can come up with a graph. The first way you can come up with a graph is by doing a t-chart. Okay, so if I was to take x, split it into the square root of x, I would get I. If I take 0 and the square root of 0 is 0, 1, the square root of 1 is 1, and the square root of 4 is 2. So now I can take these x and y coordinates and I can plot them. You cannot plot imaginary numbers on a regular coordinate plane, so we're going to start with the 0, 0 point, and there's your dot. There's the 1, 1 dot, and then finally the 4, 2 dot. Alright, connect all those dots, and this is what the parent function of the square root looks like. Alright, so we're going to start with that parent function every single time. Just again, I've already said this, but note we cannot graph imaginary numbers on a coordinate plane, therefore the graph always stops at x equals 0 when you're talking about the parent function. Alright, not only are we going to graph the square root, but you're also going to be responsible for doing cubed root. Okay, so we can set the t-chart up the same way. Now here you can take the cubed root of negative numbers. So when we plot these points, the point -4, -1.5, 9 would be here, and then -1 is there. It also hits the origin 0, 0, and then the cubed root of 1 is 1, and the cubed root of 4 is 1.59. Alright, so this graph kind of makes an S looking shape, and that is what the parent function looks like every time. Alright, since the index number, or the root number, is odd, we can graph the functions for all x values. Therefore, the domain is all real numbers. We've talked about domain and range a little bit before. Alright, so now we're going to talk about the transformations. So, when you graph functions, you always start with the parent function. Okay? Now, let's talk about what you do. Numbers that are added and subtracted outside the parentheses or grouping symbols make the function move up and down. Alright, you should remember that, hopefully. It'll come back to you. So here's our parent function again, and this is what our parent function looks like. So you're going to start at the origin, and it goes off and to the right, up and to the right. So what if I gave you the function f of x equals the square root of x plus 3? The plus 3 is outside the grouping symbols, so it's going to shift the function up and down. And as you can see, the origin point, 0, 0, has just been moved up 3, and then it's the exact same shape. Okay, so numbers outside the parentheses move the function up and down. Oops, sorry about that. The next one is when you have numbers that are inside the parentheses or grouping symbols. Alright, when they're inside the parentheses or grouping symbols, they're going to move it to the left and right. And remember, we talked about this last semester, that people are different on the inside, so when the number's on the inside, you have to think opposite. Alright, so again, here's our parent function. So it's going to start at the origin, it goes up and to the right, and go back to the origin, go down and to the left. Kind of makes an S looking shape. Alright. This function, since I have a -4 on the inside of the grouping symbols, the radical symbol, it's going to actually, you would think a -4 would go to the left, but it doesn't. A -4 is going to shift it to the right. So again, you're just going to take your origin point, and instead of being at 0, 0, it's going to be at 4, and then you're going to go up and to the right, down and to the left. And one more thing, we're not going to do the multiplication right now, we're just going to do the adding inside and outside parentheses, and then we're also going to do when a negative sign is in front of the function, it makes the function reflect on the x-axis. So there's your original function again, that's your parent function, and then we have f of x equals negative x squared, f of x equals negative square root of x. So this one has started at the origin point, and instead of going up and to the right, it reflected it, and it went down and to the left. Down and to the right, sorry. Alright. So we're going to try two more. So we're going to describe the transformations, then we're going to graph them. So this is f of x equals the square root of x plus 2 minus 3. So the 2 is on the inside of the parentheses, or grouping symbol, so it's going to move it to the left 2 units because it's the opposite. And then the minus 3 is going to shift it down. So we're going to start with the parent function. It's in the center here. And then you take that origin point and go down 3, left 2, and that's your new origin point. Okay, and then you just go up and to the right. What if you had this one? Negative cubed root of x minus 1. So you're going to go 1 unit to the right because it's a -1 on the inside, and the negative sign is going to make us flip or reflect it. So this graph is going to look crazy. First you have to think this f function right here is the original function. And then since I have to take the origin point and I'm going to move it 1 to the right, and instead of going up and to the right, I'm going to go up and to the left because it's reflected now. Alright? Alright, now we're going to do inverse functions. So hopefully this won't take too long. A couple more minutes. Things you need to know about inverses. One, you denote an inverse by saying f to the negative 1 power, f inverse of x. You just pronounce it f inverse of x. The graph of the function reflects over the line y equals x to become the inverse. So this just gives you a graph, and we'll talk more about this later. But the line in the very center, the b line, is y equals x. And these two other graphs, lines are reflected over the line, the b line. So therefore, those are two inverses of each other. All right. You can find the inverse algebraically by using the following 4 steps. So it's important. This is what we're going to be doing in the rest of this lesson, is you need to write these 4 steps down. Okay. Step 1, replace the f of x with y so that we can work with it. Then you're going to switch the x and the y. Next, get the y by itself. And finally, replace the y with f of negative 1x, or f inverse. Okay. We're going to work 2 problems, and then we'll be finished. Okay. Start with the one on the left. F of x equals 5x plus 4. So remember what the first step was? Replace the f of x with y. So that's pretty easy. You're not doing any math here. So I just exact same thing, except the f of x becomes the y. All right. Second step, switch the x and the y. So don't move anything else. Don't move plus signs. Don't move equal signs. Just literally switch the x and the y in their spots. All right. The next step is to get the y by itself. So if I want to get the y by itself, I'm going to have to subtract 4 from both sides. And then, how do I get y by itself? So it has 5y, divide both sides by 5. All right. Everything is divided by 5, so leave it written like this. And then finally, step number 4, not doing any math here either. I'm going to replace y with the inverse function. And therefore I know that the original function is the inverse, and now I have the original function is itself, and now I know the inverse of the function. Okay, so these 4 steps are going to remain the same no matter what my equation is. So step number 1, replace the f of x with y. Step number 2, switch the x and the y. Step number 3, get the y by itself. So here we go. What would I need to do? I need to get rid of that divided by 4 first by multiplying by 4. Then I need to get rid of the square root, and we just did problems like this. You get rid of square root by squaring. So 4 squared is 16, x squared is x squared. And now I still need the y by itself, so I'm going to add 3 to both sides. Now the y by itself, so the last thing I need to do is replace the y with the inverse notation. And there we have it. Alright, we're going to cover these 2 topics when we get to class next time, and then the following class period we'll be taking a quiz over the this one and the previous 2 presentations. Alright, so I will see you soon.